Good morning, 8th grade math students, and welcome to virtual math class. Today we're going to continue our learning about functions. Specifically, we will be talking about if a function is linear or nonlinear. I know that we've already talked about this quite a bit, but today's objective is that students will be able to determine if a function is linear or nonlinear. So we are going to be looking at equations, graphs, tables, and then determining what would make that function linear or nonlinear. So it's going to be pretty easy. Parts of it are a little difficult, but I promise that this is much easier than our last lesson. So remember that linear means straight. So for a function to be linear, it must be a straight line. If it is not straight, then it is non-linear. Pretty straightforward there. So here we have some examples of linear lines. So each of these examples show that they are straight lines. Nonlinear just means that there's some curve to our line whenever it's graphed. So this is probably the easiest part to tell because everyone should know what a straight line looks like. And if it's a straight line, it is linear. If it is not straight, it is nonlinear. So now let's talk about equations. So the last slide talked about graphs. This one we are about equations. So if the equation is in slope-intercept form, y equals mx plus b or y equals mx, those would be linear functions. So if you have y equals a given number, y equals any given number, let's say that it is y equals 8, for example. If I have y equals 8, that is a given number. So any given number, it doesn't matter what the given number is, that would be, if it's y equals the number, that would be a horizontal line. So the same thing happens whenever I have x equals a given number. So if I have that, let's say x equals 5, that would be a vertical line. And it doesn't matter if it is x equals 5 or x equals 1/2. It doesn't matter. If x equals a number, that's going to be a vertical line and it would be a straight line. So if I have a variable that is on top of a fraction, so let's say I have y equals x over 2. So I have the variable on top. If x is on top, it is linear. Even if it's like y equals x over 2 plus 4, still linear. So it doesn't matter if x is on top, it is linear. Now let's talk about nonlinear. So if you see an exponent and it doesn't matter where the exponent is. So let's say that we have like y equals 2x, 2 to the power of x, that is nonlinear. Let's say that we have y equals x to the third power. Anytime you see an exponent, it doesn't matter where it's at, it is going to be nonlinear. If you see a square root, let's say y equals the square root of x. If you see the square root, it is nonlinear. And then lastly, if x is on top, it is linear. If x is on the bottom of a fraction, it's going to be nonlinear. So if you have y equals 2 over x, that's nonlinear. And again, it doesn't matter if you have like plus another number, it is still nonlinear if the variable is on the bottom of the fraction. So now let's look at some examples. So my first example, I have y equals 2x minus 7. That is in slope-intercept form. So would that be linear or nonlinear? That would be linear. On the next one, I have an exponent. So I have y equals negative 4x to the power of 8 plus 5. If there is an exponent, does that make it linear or nonlinear? Nonlinear. So next example, I have y equals 9x. So that isn't slope-intercept form because that would just mean I could do plus 0 for my y-intercept. Same thing, y equals 9x. So that is in slope-intercept form. So is that linear or nonlinear? It is linear. Next example, I have y equals negative 10 over x plus 3/4. I have my variable in the bottom. If the variable is in the bottom, is it linear or nonlinear? Nonlinear. Sorry. Next example, I have y equals 6 to the power of x plus 6. Is that linear or nonlinear? Non, because I have an exponent. Anytime I have an exponent, it is nonlinear. Next example, I have y equals x minus 8. That is in slope-intercept form, so is that linear or nonlinear? That is linear. And lastly, I have y equals 3 over 10. Remember, if I have y equals a number, any number, it doesn't matter what the number is, it is linear. So I hope this helps. I know that this is a lot, and looking at equations and determining if they're linear or nonlinear is a new concept, but if you refer back to these examples and look at that at the comparison on the last slide, I promise you will do well, and that you you can get this. So just refer back to these if you are struggling at all. So, what determines if a function is linear? So, for a function to be linear, it has to have a constant rate of change. So, that means that between any given points, the rate of change or the slope must be the same. So, if I'm looking at a table, whichever 2 points that I choose, it has to have the same slope. So, first example, again, so first of all, let's recall that to find my slope from a table, it is the change in y divided by the change in x. So it's how y is changing over how x is changing. So to get from 8 to 10, I am adding 2. To get from 10 to 12, I am adding 2. Now for x, to get from 14 to 15, I'm adding 1. To get from 15 to 16, I'm adding 1. So if I'm looking at my first example, this one right here, between those 2 points, my slope would be 2 over 1. If I'm looking at my second 2 points, again, my slope is 2 over 1. So if I get the same thing for each time, it would be linear. So I got the same thing each time, so it is linear. If I wouldn't get the same thing, if I was like adding by 2 and then by 3 and I got different numbers, it's nonlinear. But on this one, I get the same thing. It's going up by the same thing each time, so it is linear. Next example, so to get from 9 to 5, I am subtracting 4. To get from 11 to 12, I am adding 1. So for my slope here, it would be negative 4 over 1, which equals negative 4. So for my next example, to get from 5 to 4, I am subtracting 1. To get from 12 to 13, I am adding 1. So that slope there would be negative 1 over positive 1, which equals negative 1. So on one, I got negative 4, and then on the second time I did, I got negative 1. So since those are not the same number, my answer is non-linear because it has to have a constant rate of change for it to be linear. So it's not changing by the same number each time, which means that it will be non-linear. Next example, to get from 3 to 10, I am adding 7. To get from 2 to 6, I am adding 4. So my slope, I do y on top, my slope would be 7 over 4 for that one. So for my next one, I'm going from 10 to 16, which will be adding 6, and then I am going from 6 to 10, which will be adding 4. So my slope would be 6 over 4. So I had 7 over 4 and then I had 6 over 4. Those are not the same numbers. So since they are not the same, my answer again is nonlinear because it has to have a constant rate of change. And our last example, to get from 20 to negative 4, I am subtracting 24. To get from negative 10 to positive 14, I am adding 24. So for this slope or rate of change, it would be negative 24 over positive 24, which is going to equal negative 1. Now I look at between my second points. To get from negative 4 to negative 10, I am subtracting 6. To get from 14 to 20, I am adding 6. So the slope on this one would be negative 6 over positive 6, and negative 6 divided by positive 6 is negative 1. So yes, this one is going up by different numbers each time. I went minus 24 and then minus 6 and then plus 24 and then plus 6. However, it reduces to be the same number. So as long as it reduces to be the same number, it is still linear. So if it reduces to be the same number, it is still linear, even though I'm adding different numbers. So It doesn't matter. All that means whenever this happens is that they skipped some numbers in their table. They don't have every number listed that would be on the line. So I know that this is a little confusing, but I also we've already talked a lot about how to find the slope from a table. So this is kind of just doing that twice. We find the slope twice, and then if we get the same number each time, it's linear. If it's different numbers, it is non-linear. So if you have any questions, please let me know. I'm confident that you guys are doing amazing and that you guys can get this because you are all very smart and I've been so impressed with you this year.